Now, in this lecture, we'll find out the radius of the circle. In the drawing, we have a circle. Inside this circle, we have chord dB that is equal to 2 units. Chord AC equals to square root of 2 units in length. And this angle BED equals to 45 degrees. Our mission is to find out the radius of this circle. In order to find out the radius of this circle, we use two rules. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Repeat again. We have this rule that states that the central angle is twice as big as the peripheral angle resting on the same chord. So we have here peripheral angle ACB, and this is the central angle AOB. And according to this rule, the central angle AOB, because of the central angle AOB rests on chord AB and the peripheral angle ACB rests on the same chord AB, therefore the central angle AOB is twice as big as the peripheral angle ACB. That is to say, angle AOB, the central angle AOB, equals to 2 times this angle, the peripheral angle ACB. Okay, AOB equals to 2 times ACB. Okay, and we will use also the second rule, that is the second law, that is the law of cosines. So this is triangle ABC, that could be any triangle. The law of cosines is true in any triangle. So side AB equals to A units in its length, side AC equals to B units in its length, side BC equals to C units in its length, and this angle BAC equals to theta. And according to the law of cosines, in this triangle ABC, C square equals to A square plus B square minus 2 times A times B times cosine theta. Repeat again. C square equals to A square plus B square minus 2 times A times B times cosine theta. From this equation, it is very easy to arrive to this equation, that cosine theta equals to A square plus B square minus C square over 2 times A times B. Again, cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay. We define the center of this circle, this point is O. In the next step, we'll join points O and B together. A straight line. We'll join points O and D together by a straight line. We join points A and O together by a straight line. And finally, we join points O and C together by a straight line. So those 4 line segments OB, OD, OA, and OC are the radii of this circle. Why? Because of the fact that they start from the center of the circle, point O, and the ends and points B, D, A, and C at any point where the points on the circle itself. This is exactly the definition of a radius. We define the radius of this circle as capital R, so OB will be equal to capital R. OD, line segment OD equals to capital R. Line segment OA equals also to capital R. And finally, line segment OC equals to capital R. Okay. So we will focus on chord DB. We have angle BAD. This angle BAD rests on chord BD. We define the peripheral angle BAD as x over 2. Therefore, the same we have the central angle BOD that rests on the same chord called BD. Therefore, it must be also it must be twice as big as this peripheral angle that rests on chord DB. So this peripheral angle equals to x over 2. Therefore, the central angle BOD must be equal to 2 times x over 2, that is x. In the next step, we will focus on chord AC. We have peripheral angle CDA. This peripheral angle rests on chord AC. So we define peripheral angle CDA as y over 2. And therefore, the central angle AOC that rests on the same chord, chord AC, must be equal to 2 times y over 2, that is y. Okay. In the next step, we will implement the law of cosines on the green triangle OBD. According to the law of cosines in the green triangle OBD, cosine x equals to r squared plus r squared minus bd squared. Bd equals to 2 units in itself, therefore bd squared is 2 squared, that is 4, over 2 times r. So this equation number 1, cosine x equals to r squared plus r squared minus 4 over 2 times r, is the implementation of the law of cosines on the green triangle OBD. So cosine x equals to r squared plus r squared is 2r squared minus 4 over 2 times r is 2r squared. Or cosine x, according to this equation number 1, equals to, we'll split this expression into 2 parts. The first part will be 2r square over 2r square minus 4 over 2r square. So cosine x equals to 2r square over 2r square is of course 1 minus, here we have 4 over 2 is 2, so in the numerator we have 2 over r square. Okay, cosine x equals to 1 minus 2 over r square according to equation number 1. In the next step, we'll implement the law of cosines on the yellow triangle, triangle ACO. In the yellow triangle, triangle ACO, according to the law of cosines, we'll get the cosine y equals to r square plus r square minus square root of 2 square is 2 over 2 times r times r. So according to the law of cosines, we found out that in the yellow triangle, triangle ACD, cosine y equals to r square plus r square over 2 times r times r. So here cosine y equals to r square plus r square is 2r square minus 2 over 2r square. We split this expression into 2 parts. So here it will be, the first part will be 2r square over 2r square. The second part will be minus 2 over 2r square. So we get actually that cosine y equals to 2r square over 2r square is 1. And here we have minus 2 over 2 is minus 1, so in the numerator we have minus 1 over r square. Okay. In the next step, we will define one over r square is t, and we substitute 1 over r squared by t in this equation, equation number 2, and we get that according to equation number 1, and we get that according to equation number 1, cosine x equals to 1 minus 2, and 1 over r squared is t, so it is 1 minus 2t. So cosine x equals to 1 minus 2t, according to equation number 1. And we'll substitute here 1 over r squared by t, and we get it according to equation number 2. Cosine y equals to 1 minus 1 over r squared is t, so we substitute 1 over r squared by t. So those are the two equations. We have already found out that here actually in the next step we'll focus on the pink triangle, triangle AD. But before that we focus on the straight line AB. We have this angle is equal to 45 degrees, and according to rule number 1, the sum of the angles on one side of the straight line is equal to 180 degrees. The missing angle must be equal to 145 degrees. And we also know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, in the pink triangle, triangle AED, we'll get that each angle we have inside triangle AED, we have angle x over 2 plus y over 2 plus 135 degrees equals to 180 degrees. So this is according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So it is also in the pink triangle, triangle AED. Okay. The pink triangle, triangle AED. Here we subtract from this equation minus 135 degrees, and we get that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees is 45 degrees. Conclusion, we found out that x over 2 plus y over 2 equals to 45 degrees. We multiply this equation by 2, and we get that x over 2 times 2 is x, plus y over 2 times 2 is y, equals to 45 degrees times 2 is 90 degrees. So in conclusion, we found out that x plus y equals to 90 degrees. We subtract x from this equation, and we get that y equals to 90 degrees minus x. Okay. we return to the two questions. So we just right now found out that y equals to 90 degrees minus x. Therefore, we'll substitute y in this equation, equation number 2, by 90 degrees minus 2. We'll substitute y in this equation, equation number 2, by 90 degrees minus x. And we get that cosine y is cosine 90 degrees minus x equals 90 degrees minus x equals to y. We substitute 90 degrees minus x by y. And we have the trigonometric identity that sinus 90 degrees cosine 90 degrees minus theta equals to sinus theta. According to this trigonometric identity, we get that cosine 90 degrees minus x equals to sinus x. So, in conclusion, we found out that cosine y equals to sinus x. Cosine y equals to sinus x. Okay. So I can substitute cosine y in this equation, equation number 1, by sinus x. We do it now and we get that cosine y is sinus x, so sinus x equals to 1 minus t. And according to equation number 1, we have already found out that cosine x equals to 1 minus 2t. Okay, and we have the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. We use this trigonometric identity in our two equations. So sinus square theta, sinus x equals to 1 minus t, therefore sinus square x equals to 1 minus t squared plus cosine square theta, cosine x equals to 1 minus 2t, therefore cosine square x equals to 1 minus 2t squared, and it must be equal to 1 according to this trigonometric identity. So I found out that 1 minus t squared plus 1 minus 2t squared equals to 1. We'll open the brackets on this side of this equation, and we get that according to this equation 1 minus t squared equals to 1 squared, that is 1 plus t squared minus 2t plus 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t, is equal to 1. So we have here 4t squared plus t squared is 5t squared, and we have minus 2t minus 4t is minus 6t, and here we have 1 on both sides of the equation, so 1 will get cancelled. Here we have 0, and we left only with 1, so it is plus 1 equals to 0. So we found out that 5t squared minus 60 plus 1 equals to 0. So here we have 5t squared, and minus 60 is minus 5t minus t, so we substitute minus 60 by minus 5t minus t, plus 1 equals to 0. In the next step, we take out 5t as a common factor from 5t squared and also from minus 5t. So what is left from 5t squared after we took from it 5t as a common factor? What is left is actually t. And what is left from minus 5t after we took from it 5t as a common factor? What is left is minus 1 equals to, we take out minus 1 as a common factor from those two expressions, minus t is minus 1. What is left from minus t after we took from it minus 1 as a common factor? What is left is actually t. And what is left from 1 after we took from it minus 1 as a common factor? What is left is actually minus 1. Why? Because minus 1 times minus 1 is 1. All equals to 0. In the next step, we take t minus 1 as a common factor from those two expressions. So t minus 1 is taken as a common factor. What is left from 5t times t minus 1 after we took from it t minus 1 as a common factor? What is left is actually 5t. And what is left from minus t minus 1 after we took from it t minus 1 as a common factor? What is left is actually minus 1 is equal to 0. So here we will have two solutions that are possible for t. Either t minus 1 equals to 0, or 5t minus 1 equals to 0. So t minus 1 equals to 0, therefore t equals to 1. According to our definition, t equals to 1 over r squared. So we substitute t here by 1 over r squared, so t is 1 over r squared. It is equal to 1. We multiply this equation by r squared, and we get that 1 equals to r squared. We take a root out of this equation, and we get that r equals to the square root of 1. So we have two solutions. The first solution that is r equals to the positive square root of 1, and the second solution, and so the positive square root of 1 is 1, and the second solution is that r equals to negative square root of 1, that is minus 1. R equals to minus 1. But because of the fact that the radius is a length and the length must be a positive number, r equals to minus 1, that is a negative number, is not possible, so we cancel the solution, and we left only with the solution that r, the radius of the circle, equals to 1 unit in its length. And next step we take care to the second solution. So we have 5t minus 1 equals to 0, so 5t equals to 1. We divide this equation by 5, and we get that t equals to 1 over 5. T t is 1 over square, so t equals to 1 over r square, so we substitute t by 1 over r square, so it is equal to 1 over 5. We cross multiply this equation and we get that r square equals to 5. We take root from this equation and we get that r equals to the square root of 5. So we have here two solutions that are possible. Either r equals to the positive square root of 5 or r equals to the negative square root of 5. And because of the fact that r is a length, it cannot be equal to a negative number, so r equals to the negative square root of 5 is not correct. We cancel the solution, so we left only with r is equal to the positive square root of 5. Okay. So here we have in the drawing we have called dB. Called dB doesn't pass for the center of the circle, that is to say, it doesn't pass for point O, therefore it is not the diameter of the circle. And because of the fact that the diameter of any circle is the longest chord, you can conclude from it that the diameter of this circle, that is 2r, must be greater than dB, that is not the diameter. So 2r is greater than chord dB. Found out that 2r is greater than dB. It is given us in the question that dB equals to 2, so it's given us in the question that dB equals to 2 units. Therefore, we substitute dB by 2, and we get that 2r is greater than dB, that is 2. We divide this equation by 2, and we get that r is greater than 1. So the solution that r equals to 1 is not correct, because r must be greater than 1. So we cancel the solution, and we left only with the solution that r equals to the square root of 5 units. That is to say, in terms of numbers, it is equal to 2.236 units. Okay, and that is the answer to the question. I repeat again, the radius of this circle, r, or capital R, equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. Okay, thank you very much.